All right, welcome back to another episode of Smart Contract Design. Today we're going to be going through a decentralized auction with try-catch error handling. So the goal of the project was to create a trustless environment where users can create auctions and place bids using the ERC20 tokens. We also want to make sure that the funds are securely held in escrow until the auction finalizes. So, the core engine, of course, of the project is, of course, the contract itself, the auction systems. So we have the IERC20 interface. We have the auction item, or the contract, the auction contract, struct to hold all relevant data for a single auction. And then, let's see, constructor sets the token address when the contract is deployed. So all this, it follows the instructions of the assignment here. All right. Then we have our counter. All right, so then we have the place bid function, validity checks, store the previous bidder, and then we have step by step. First, we have the escrow. We have escrow the new bid. So refund the previous bidder if there was one. So these are try, if else try catch statements. So catch revert strings emitted by the tokens and catch low level errors. All right, finalize the auction. Make sure that the auction hasn't been finalized already. If they were bids, transfer the highest bid to the seller. So all of this. And then we have the get auction details function as well. And then we also have the mock contracts for testing here. All right, so basically some obstacles in the architectural design. So initially, we're pushing this refund directly to the play. We are pushing this refund directly during the place bid transaction. So the obstacle here is that if the refund transfer fails, it could revert the entire transaction. And it's a classic denial of service vulnerability. So we wrapped the refund logic in a try-catch block. So if the refund fails, we catch the error and allow the new bid to succeed anyway. And then, so there were, just make sure also, another thing, make sure you're looking at the right version. So this is version 5. Ether version 5, so make sure you pay attention to that. Otherwise, there are some syntactical discrepancies. And then, something else to pay attention to: hard coding the file path can break the script if the workplace structure changes slightly. So we wrote a kind of a custom helper function that acts as a search, scanning multiple directories until the successful one successfully locates the JSON artifact. All right, so yeah. So we see here, helper function here. All right, so without further ado, let's just go ahead and see this in action. So you'll see all of the automation here in the test auction JavaScript file. You'll see that come out in the terminal here when we do this. We're also going to be doing negative testing as well, or negative cases. So you'll see those tests as well. So let's go ahead and compile here and run our automation testing. Make sure this all goes smoothly. All right, so it looks like everything. Okay, good, yes. So we deployed the contracts. Let's see. Yeah, so as you can see in the console output, good. Yeah, so deployed our mock ERC20 token in the auction contract. We mint the testing tokens to two different bidders, and then you can see we intentionally try to break some of the rules. We attempt to finalize an auction early, that's blocked. Tries to bid below the minimum threshold, that's blocked. And bidder 2 tries to place a bid lower than bidder 1's current highest bid, which is also blocked. Here. All right, so the happy path, it successfully processes a valid bid from bidder 1. So we then simulate an auction that expires, immediately. Bidder 1 tries to bid on the expired auction, and it's successfully blocked. All right, yeah. Bidder 1 places, okay, happy path here. Yeah, and all this code is uploaded as well. And then finally, the script attempts to finalize the exact same auction a second time. It's a double finalization of an auction, and that is passed, so all tests pass successfully. So that is all we have today. But just kind of as a summary, the contract protects the seller's escrow, defends against DOS vectors during bidding wars, and is fully verifiable through the JavaScript testing JavaScript automation testing. All right, that is all for now. More to follow.